In the fascinating world of chemistry, we're looking at other types of bonding. We're looking at 3 here specifically today versus the network bond. It's a covalent bond in a crystalline form, metallic bond, a metal-to-metal bond with a free movement of electrons, and a hydrogen bond. We're going to focus on the most here. It's a covalent bond using hydrogen and a non-metal. It causes attraction between the molecules by charge. All right, so let's look at a network bond. First, an example of this would be diamond or glass. So diamond is usually carbon 8 in a crystalline form, and there's different forms of it. That's what we get different facets and different energy and different light. All right, also an example, glass, CiO2, silicon dioxide. It's like carbon dioxide. It's got double bonds on both sides. Because of that structure, it can cross-link between it and give it almost like a solid and liquid form. We'll talk about that in class later. All right, next, metallic bond. We said it's a metal bond caused by a free movement of electron. So if we give you an example of sodium to sodium, those electrons with one on there will move easily. And then lastly, the metallic bond. It's a polar bond. It's a molecule of opposite charge across the structure. So let's take a look. The best example of a polar bond is water. All right, so here's our structure for water. We've done it before. Now, when we look at this, hydrogen only has one valence electron, and it's stuck here at the bond. So there's literally nothing on the outside of this hydrogen to shield it from the outside. So this entire side is positive, okay? These unbound electrons of course are negative, so the opposite side is negative. So we have a positive on one side, a negative on one side. To have a polar bond, have to have hydrogen and at least one unbonded electron pairs. Okay. All right. So here's some examples. We'll do these in class. All right, let's look at a hybridization. Last thing we're going to look at. Rearrangement or mutation of orbitals for covalent bonding based on the number of bond sites. Remember, we have S, P, D, and F. I want to use those to bond. So let's go back and look at our example of water again. Here's our structure. Now, a bond here and a bond here. So that's 2. And all bonds counts as a single bond site, double, triple, or only are 1. So even if you have a double bond or a triple bond, that's still only 1 bond site. Then we have 2 more unbonded sites, so the total of 4 bond sites, 2 unbound electron pairs. So look at our orbitals. We have S, 1s, we have 3 p's, we have 5 d's. That's as far as I'll need to go. So if I need 4 bond sites, I'm going to grab 1s, 1, 2, 3 p's, so that I'm going to take those and rearrange them so they're all the same level, and the hybridization for this bond is called sp3. All right, we'll look at all of these for hybridization and polarity. Hopefully that wasn't too bad. Take care. Be good. Bye.